Hi everybody, this is the first video of arrays and hashing playlist, and in this we'll start with two sum. Let's get into the question first of all. This question tells us to find or return two indexes. Okay, two indexes out of a list that they are provided in such a way that addition of the values at those two indexes should be equal to the target. Alright, let's understand with this example. Here the target is 7. So what two values I should add out of this uh, list so that I can get 7? So it's quite obvious as of now that adding 3 and 4 will result in 7. Okay, and the index are 0 comma 1. So we need to return the index and not the value. There are few things we need to take care of, that we need to return the smaller index first. Okay, and there will be exactly one pair of the result. Okay, so it won't happen that there are multiple ways we are able to achieve 7. There will be only single pair through which we will be able to achieve this answer, that is 7. Fine. So let's get right into it. First of all, the brute force approach is quite simple. I'll take 3. Okay, I'll take 3 and add each and every number to this 3, that is 3 plus 4, 3 plus 5, 3 plus 6, and see if anything matches with 7. Okay, and whenever I get something that matches with 7, I'll return those indexes. Why? Because there is exactly one solution for this particular answer. Okay, so whenever we get it, we'll return it. But that is not a good solution or good approach for this problem. Alright, if I want to do everything in a single pass, it is possible. So let's see how. We will be using a hash map. Hash map is nothing but a frequency table kind of structure. Okay, a tabular structure, you can think of it, with whatever data you want to store. Okay, and however you want to store it. Here in this question, we will be storing the number. So if I am talking about 3, I will be storing 3 and the index of that number. I'll store 3 comma 0, something like this. Okay. If I'm storing 4, I'll store 4 1, something like that. That is our way of using hash map. Okay. But how it will be beneficial, let's see. For each number, for each number I am passing, I'll note few things. What I need to add in this 3 in order to get 7, alright, in order to reach the target. So I need 4, correct? Now, again, we don't have any kind of memory, so that's why we are using hash map. So I'll check, have I seen 4 in this hash map? If yes, that will be the answer, correct? I think let's do a try run. What I should add in 3 to get 7, so I should add to be added. Okay, now I'll check it in the hash map available, that 4 is available or not. 4 is not available anywhere as of now, so I'll move on to the next one. 4, what I should add in 4 to get 7? 4 minus 7 minus 4, that is 3. This is nothing but to be added. Now if you remember, uh, once we went to 3, okay, we will be storing it somewhere here like this. Okay, you are not usable as of now, but let's see if you come into use later on. Now at this point, as you can see, we have got 3 in to be added format. So I'll check in the hash map if 3 is available or not. And yes, 3 is available. At what index? It's available at 0th index. So I'll return hash map of to be added, something like that, to be added, comma, current index. Okay, why? Because remember we need to provide smaller index first, and obviously whatever we have passed will be obviously have smaller index. That's why this is the format in which I'll be returning the answer, and that's how we will solve it. Now let's try to implement this. How we will be implementing it is, let's make a hash map first. Hash map equal to empty. Okay, empty hash map. Beautiful. I'll do for num in nums if to add equal to, mm, to add is nothing but, mm, target minus num, target minus num. Okay. This is something we need to add. If to add in hash map, in that case we already know that if to add is present, I'll return. Okay, I need to return a list, so I'll return a list. In what manner? Hash map of to add in current index. Now please note, as we are iterating by nums, we won't be able to get current index. So in this case, I need to change my approach a bit in order to iterate via index. So I'll do nothing but range of len of nums. So that's how we will be getting index in Python and 4. So now we are here. I need to do something like this, and yes, now I think we are good to go. In case that to add is not present in the hash map, we will be storing this current number wherever we are in the hash map, so that it might be useful in the future. So I'll add it hash map, and current number is nothing but nums of I, and I'll store its index as well, because I don't want to get or find their index again. Okay? And I don't think we need to add a return statement here, because we already know that there will be exactly one answer here, so it should work properly. Let's see if I messed up. No, I didn't. Okay. So that's how you would solve this particular question to some in a single pass. Okay. Now let's take some another questions, that is valid anagram. What is an anagram? Let's read the definition first. An anagram is a string that contains the exact same character as another string, but the order of character can be different. So, a good example would be a race car that they have already given. Race car and car race will obviously have same set of characters. Oh, again, it might be different, right? The order might be different, but they are same number of character in same frequency. That's why this is an valid anagram. while this is not, because M is not present here, R is not present on the other string. Fine. Now, one approach that initially that came to my mind was using a set, but I don't think set is a appropriate one in this case, because let's say I take two strings, that is cake and cakes. Cake. Okay. I know this is not a word, but you will get the gist of this thing. Cake or cakes. If I use set of it, okay, set of string 1 and string 2, okay, what I'll get is, for both I'll get cake. Okay. But this is not correct. Why? Because uh, it has double C, which is not right. Okay, so it won't be uh, accurate enough, I believe. Let me know if I'm wrong, and if you could suggest any example of it. Here in this case, let's try the regular approach of using frequency table. Okay. But first, I'll check the length of it. If length of s not equal to length of t, in that case, I'll return false. Yeah, we need to return false only, because if they are not of same length, obviously it won't contain same frequency of characters. Mm, let me try. I want to try it. Okay, I want to try it. Set of s equal to set of t. Okay. If they are true, then they should be a valid anagram. Okay. Let's see if it fails or not. Because please note, we have added this check again. Wait, I don't think it should fail, but let's see. Yeah, here it's failing. Okay, what is the case? It's BBCC and this is CCBC. Yeah, this is a good one. As I mentioned, they have same set of characters, okay, but in different proportion they are using, and again they have same length as well, so they will bypass the first condition and then fail ahead. So this is one thing that actually came into my mind, and I thought it would be good to discuss. Okay, in case someone was thinking in this particular direction. If not, uh, you are smarter than me. Okay, don't worry. Now let's do a robust approach, which I know will work properly. I'll create a hash map, empty one. Okay. Then I'll for I in a range length of s, because both will have same length, so I can talk about length of s or length of t, doesn't matter. Mm, hash map 1, hash map 2. Why we cannot use a single hash map again? uh, it might be possible that second string may contain certain character in such format that even though there are no odds in the value, but still uh, it won't be correct anagram. Okay, so I want you to try the single hash map approach and know by yourself that why it will fail. Right, I've tried all of these approach. Okay, never be afraid of trying. I've tried each and every approach and then got a suitable answer. Okay, in this way you will know that okay, why we should not do that. Okay, that's the whole point of doing this. All right, here We are in the for loop, and let's prepare a hash map. Hash map 1 of s of I. All right. Yes, s of I will be equal to plus equal to, or more better way would be hash map 1 dot get s of I. Okay, or or 0. In addition to that, I'll add one hash map of 2 t of I this time. Hash map 2 dot get t of I comma 0 plus 1. Okay. Now at the end of this for loop, we will be having two frequency table, and each of it will have same frequency in same format and everything. So that's why I believe that this solution should work. Return hash map 1 equal to hash map 2. Let's try to submit it. I have few things in my mind that might fail. Let's check it. Alright, it didn't. So the solution worked properly, and yeah, you are good to go. Alright, it beats 100%. So this is a good optimal solution for this problem. Last but not the least, here in this one we need to identify if this particular array, alright, or list contains duplicates or not. Again, we will use set return. Okay, this is first time I'm returning directly and without explaining, because it's self-explanatory, I guess. Okay, boom, we have solved it. What actually happened? If we apply set of nums, then what will happen? That duplicates will get removed. In that case, the length will decrease. And if length is not same afterwards, it means that it means that there were duplicates. So if length is not same, it means it has duplicates, and therefore this will be the solution for this one. I know it's a bit of long video, but it contains three solutions. Okay. And we have discussed all of it thoroughly, and I have tried to give you complete insight on how I am thinking in order to solve these problems. Alright. So I hope you learned good approaches and good ways, along with incorrect ways to solve a particular problem. Thank you very much.